after the particular body that we are talking about. So all of that, you will need to gather your data. So you can do primary data gathering, or you can gather from secondary sources. And what do I mean by that is data that has already been generated, is on ground already. It's not you that is gathering the data. That's your secondary sources. So depending on the problem you want to solve, you can either go out and gather the data yourself, or you can actually start pulling out the data set that has been generated and placed in databases. All right, so what do we do next when we've gathered our data? We try to spend time to study the data. So where is the data from? Like I said, is it from primary sources or from secondary sources? That is also going to inform what you are going to do to the data. Probably if it's from primary source, the cleaning might not be as tedious as if it's from secondary source. So then you need to ask yourself, what kind of variables are present in the data? I mentioned it earlier. Is it categorical variable? What is the variable of interest? For instance, now, let's say you want to determine, how many customers are, let me use this. Let's say you want to determine the likelihood of your customers to churn from using your services. Probably you're working for a telecommunications company, and you want to determine the likelihood of a customer to churn in the next 3 months. You will have to gather your data. Now, what is going to be your variable of interest, or your target variable? Your target variable will be whether the customer, the customers in the past or in the historical data, your target variable is going to be whether those customers in the past churned or not. And then from there, you're going to think of the characteristics that could make them want to churn, what characteristics differentiated those who churned and those who did not churn. And then you are going to ask yourself, are you going to measure these variables? So if you have a categorical variable, there are ways you measure it. If you have a continuous variable or a numeric variable, there are ways in which they are measured, or in which you interpret their graphs or something, the kind of graphs you're going to use and all of that. Then you are going to ask yourself, okay, so each of these variables that I have noted in my data set, what do they mean? So is either you get a variable description. For those of us that know about Kaggle or Zindi, sometimes when we want to work on a project, we usually look for the variable description or data dictionary. So where what each variable means have actually been described for us. If they have not been described, you will have to go back to those who generated the data and ask them what each of those variables, what they mean. So from there, you will ask yourself, what do I want to know from my data? And that has to do with your level of curiosity. As a data scientist, one of the soft skills that you need to have is that you have to be curious. You have to be able to ask the right questions, because if you don't know how to ask questions of your data, you won't be able to even know how to get the answers to the questions. So yes, you have to be curious. You have to be able to ask questions, and then you take those questions one at a time and then begin to explore your data. So you could start with your target variable, which is the variable of interest, what you want to, under that column of, under that variable that listed which of the customers churned or not, you can actually start to ask, okay, so in the past, how many customers have churned? What is the percentage of the customers that churned? Okay, do we have more of loyal customers, or do we have more of churners in our data set? And so that from there, you can move on and say, okay, so what is the distribution of the variables, the independent variables? Okay, so do we have, let's say we have the age of the customers as another variable. You can decide to ask yourself, okay, so what is the category of the age category of churners? Do we have more of churners who are older or who are seniors, or do we have more of them as young people? You as the data scientist is going to decide, okay, so what is your cutoff? What determines who belongs to the young category or the middle-aged category or the senior category. So how many of your channels are in that category? And you can do that by checking the distribution of your univariate variables. What do I mean by univariate variables? I'm talking about variables that have just one level. For instance, you could decide to check the distribution of your age. That's what I mean. Age is just one category. So you can use your histogram to get to know what is the trend. Do we have more of older people or do we have more of younger people? Then after you have done all of that, you can now move on to start comparing each of the variables with one another. And so we can have bivariate variables. That's when you actually comparing two variables to each other. And then we have more, you can also pair more than one variable together. And so we have multivariate variables. So I said check multiple variables at once. You can use matrix plots. For instance, you can use your heat map to check the relationship between each of the variables and even with the target variable. Okay, I would like to pause here and ask, please, are you getting what I'm saying? Can you hear me clearly?
Yes.
Okay, so can I move on?
Go ahead.
Thank you. So the next one is what methods or techniques should I use? So there are different EDA techniques depending on the type of data that you have at hand. So for instance, we have the descriptive statistics, and that has to do with you describing your data using what we call the 5 summary stats, which has to do with your minimum. That was what I showed earlier, where you saw the minimum, the maximum, the mean, the median, and let me remember again. Okay, so we have, when we say 5 summary stats, we talk about the mean. We have the 25th percentile, we have the 50th percentile or the median, then we have the 75th percentile, and then we have the maximum. Then you can also go ahead to talk about your mean, which is the typical value in your variable, and then the standard deviation, which is how far away your the values of your variable are from the mean. All of this has a lot of information that you can gain from it. For instance, if you have a lot of values that are like more than 3 standard deviation away from your mean, you know that you have outliers in your data set. And what do I mean? I'm talking about you have unusual observations in your data sets. For instance, probably you have monthly income as a variable in your data set, which is usually full of outliers. And so what do I mean by outliers or unusual observations? So you see people that earn way higher than the average income, or the people that earn way lower than the average income. And so that gives you an information on, okay, it gives you an information on what kind of people you are dealing with. That's number one. Are you dealing with more of low income earners, or you are dealing with more of high income earners? That's one. Then 2, it informs how you are going to treat the variables when you want to actually carry out predictions or machine learning, as we call it. So we also have another technique that we use, which is visualization. And that has to do with the use of graphs and pictures. You know, we usually say that a picture is worth more than 1,000 words. And that means that it's easier to actually visualize your data set rather than trying to understand what the number or the numeric values are. So for continuous, then also the type of graphs we use depend on whether your variables are continuous or real numbers, or they are categorical data, where your variables have been categorized into different levels. For instance, your continuous variable can be age, can be monthly income. You know, those kind of variables can assume any form of real numbers, right? But for your categorical variable, for instance, the sex, you can either be male or female, or I prefer not to say, it's still a category. So yeah, and that informs the kind of the graphs that you are going to use. So we'll discuss all of this later on. And then I would like to say that at this stage, when you are carrying out exploratory data analysis, you are not concerned about the fineness of the graphs, how fine your graph is, the color you want to use. It's when you now want to convert to explanatory analysis or explanatory analysis, where you are actually gathering the info, when you are actually you are about to present the information you have gathered to probably your audience or your stakeholders, the people that gave you the job to do, then you have to be concerned about the findings, about how your graphs can be easily read and interpreted, because most of your stakeholders might not even be technical people. So once you have cumbersome graphs, it can cause problems for you in your presentation. So, but at this stage where it's just you exploring your data, you are not concerned about whether you actually use this particular color, does this color actually blend or something. You are just about you getting the information or the underlying pattern in your data set. So the next one says, what does my statistics or visual say? Does it make sense? So you begin to read your graphs by saying, okay, is there an increasing trend? Do we have outliers in our data set? From there, you begin to note, is there an outlier? If there is an outlier, you try to find out. That's what exploratory data analysis is all about. You finding out, you gathering insight. So if I have an outlier, is it as a result of genuine observation or as a result of an error? Probably when they were imputing the data, somebody made a mistake. For instance, if you have age as a variable, and then you have somebody that's 200 years old, you know that's likely going to be an error, because hardly will you see anybody that is 200 years old, right? But if you have someone that's around 90, then you can decide to find out, okay, so this 98, is it genuine? Does it make sense? Does it make sense for us to have this outlier in this data set? And so if your outlier is not genuine, then you know that you will need to find a way to correct that. Probably you're going to remove the observation as a whole, depending on how much, what the shape of your data set is. And by that, I mean, what's the dimension of your data set, how many rows or how many number of observations that you have, before you know whether you want to delete some or you want to impute the correct thing. Probably the person that wrote 200 wanted to impute 20 or something. So you have to decide that by yourself. So from here, let's begin to now talk about the technical aspect. So we'll move on to our Jupyter notebook. But before we do that, does anybody have any question concerning what I've discussed so far? And please, can you see my screen?
Yes.
I need people to talk. Okay. Hello. Okay, let me move on then, because we need to stop very soon. Okay, so to carry out exploratory data analysis with Python, I am assuming that at least some of us have come across what Python is. It's a programming language, a versatile programming language for data science. You can also use it for web development too, but is very good for data science. And we have what we call packages or libraries that we use in Python. And these are a set of modules that help us to carry out particular tasks or functions in Python. as a language. And so one of those libraries is what we call Seaborn. And I will quickly read this to you just to save time. So I said, before embarking on a use case of EDA, let us quickly discuss around Seaborn, which is a statistical plotting library in Python, renowned for beautiful themes and default styles. So it is built on top of the Matplotlib library. That's another library that we can use for data visualizations. And then it makes learning Seaborn easier and faster. So I won't like to dwell so much on the programming aspect. It's not something we can actually learn in 15 minutes. What I would rather like to do is for us to understand the principles behind EDA. So I'll just run through how you can carry out your data analysis using Seaborn. Then we now move on to a use case where we are able to think about, okay, we are able to think about the principles behind EDA and how to carry out EDA on a use case. Okay, so let's move quickly. I could actually share the slides with you so that you can read it in your spare time. So what you do when you want to get started with a particular package is that you import the package. And we do so by saying import Seaborn as SNS. And then we use a magic, we call it a magic function. Then this percentage matplotlib inline. And so then we move on. I said when conducting EDA, especially with visualization, we try to explore distributions of univariates. I've said that before. That's one variable, that's univariate, and existing relationships between two or more variables. So now this will determine the type of graph we plot. And so generally there are two types of graph of data. We have qualitative data, also known as categorical data, and then we have quantitative data, which can either be discrete or continuous. Now, when we talk about discrete data, we are talking about variables that can be counted. And let me, an example of that is, I'm trying to think. Okay, so let me move on. Continuous data, for instance, you have age. Continuous data are data that occur in real numbers. So we can have decimal points. For instance, we can have, for instance, your weight. We can have 52.5 kg. Another person can be 53.8. So they are assuming real numbers as far as you can go. But for some variables, you can only count them. I'm trying to think of one off my head, but let's keep moving on. You can also suggest in the chat session. Okay, so what I did here was to quickly load a data set from Seaborn, and it's called tips. When you are doing this for the first time, you have to use the internet. But after that, it will have been saved in your Seaborn package. So you can just call it out anytime you want. Okay, so let's start. For your continuous data plots, you can use what we call distribution plot or displot. And so the displot shows the distribution of a univariate set of observation. Is either you plot a histogram that now has what we call kernel density estimation, or KDE. This one shows KDE. What KDE does is to show you the shape of your distribution. You can decide to include it and you can decide to remove it. And so this is the syntax or the code you can use to get a histogram of a particular variable. So inside the data set, we have what the tips data set is all about. A waiter in a restaurant collected data on the number of tips he collected in I think in 3 months or so. And he was able to also record the total bill of the people that were paying, of the customers that were paying the bills. And so we have total bill as a variable, and then we also have tips as a variable, and the number of customers that came as a group into the restaurant that day, and how much tip they paid. So let's move on. So total bill is a continuous variable, and that's why we are using the histogram. We will come to the interpretation later. For bivariate plot, that is, you want to plot two variables against one another, you can use what we call scatter plots. And so the syntax is joint plot. So this is the syntax we use to carry out a joint plot. And so this one is giving us a scatter plot, which actually shows the relationship between two continuous variables. And then it's giving us the histogram, or the distribution of each of the variable. So this is the distribution of tip, and this is the distribution of total bill. So moving on, you can decide you don't want a scatter plot, that you want it to be 3D, that's 3-dimension, and you use what we call, there is an argument here called kind. So you just use a hexagonal, I think it's called hexagonal plot or something, yeah. So X is what you just impute into the argument, and you get this. Then we move on to you wanting to plot more than two variables, and so you can use your pair plot. Looking at it here, we see that we have total bill, we have tip, and we have size. Size is the number of party, or the number of people that came as a group. And so we are able to visualize three variables at once against one another. So you can either use the pair plot, or you can use, okay, then another thing is you can decide that it's not just those three variables that you want to see. You want to see how these variables are actually splitted across a categorical variable. So what I did here was I want to see the distribution of sex. The distribution of the total bill across the gender. So for the blue dots represent male, and the orange dots represent the female. I will interpret that later when we are talking about the use case. So also you can decide to do the KDE plot. This one just gives you the shape of your distribution. It will show you whether your data set is skewed, that variable is skewed, or it's a normal distribution, it has outliers and all of that. From here, you can see that it has a tail. It has a tail here, and you can quickly see that we have some outliers. Okay, so for categorical variables, we have count plots. So count plot, what count plot does is just to give you the count using a bar, to give you the count of each of the category, each of the level of your category. So for a sex now, we have male, and then we have female. So here we can quickly see that we have more male than females come into the restaurant or pay for the bills, right? So for bivariate plots, you want to compare sex to total bill, you can use your bar plot. So bar plot is different from count plot. For count plot only takes one variable at a time, but bar plots can take two variables. And so we are using sex against total bill. And this gives you the mean of each level of the sex category. Like I said, I will interpret later on. Then we have others. If you want to, they're like categorical scatter plot. You want to see the distribution of your categorical variables. So we use strip plot or swarm plot. The syntax is here. And so you are able to see across the day that the customer came into the restaurant. You can be able to see the total bill that they paid across the different days. Then the same goes with strip plots. Then we have what we call box plots. We have box plots. So what box plot essentially does is renowned for showing us our 5 summary statistics, which is our minimum. So this using whisker and box. So looking into this graph now, we see the minimum, the first end of the whisker, and then the next line is the 25 percentile, which is the first edge of the box. Then the line in the middle of the box represents our median. The other edge, the upper edge of our box represents our 75th percentile, and the other end of the whisker represents our maximum. So the dots that you can see after our maximum are the outliers. So it shows you if there are outliers in your variable. And then also you can compare different levels of your category against your continuous variable. So you can also, here you can see that not only did I compare it across days, I also compare across females. Across the sex rather. So we have violin plots, but violin plot is like the histogram of your continuous variables. So here, this is showing me the distribution, the shape rather, the shape of my distribution, just like the KDE plot does for continuous variables. So moving on, we have what we call, the cat plots. That one is also another form of method you can use to carry out your categorical graphs. Probably you just want to impute bar plots. If you want count plots, it will display it for you. So I would like to talk about one other plot that is important, and that's your it map. So what it map does is to show you the correlation or the relationship between several variables at once. And so you are able to determine if there is especially if you are carrying out machine learning, you want to carry out predictions. So you want to know which of the independent variables actually have a real linear relationship with your target variable, so that you know which one to include, which one to drop. And so you use this it map. So the intensity of the color reveal to you the strength of the relationship between each of the variables. I hope you understand what I'm trying to say. For instance, now, if you look at the legend, you can see that if you want to know which one have a very strong relationship, and that's 1.0, and it's like cream in color. And so where we have perfect correlation, that is between variables against one, when a variable is plotted against itself, then we have a perfect correlation. You can see that it's cream in color. For those that have at least some strong, moderate correlation with one another, we can see that it's in black. And so that's why we have -5, 0.5. You know, your correlation is between your correlation is between -1 to 0 to +1. So if you have -1, you have perfect negative correlation. And that means the more one is going up, the other is going down. And if you have if you have 0, that means it has no correlation whatsoever. They don't have any obvious relationship with one another. Then if you have +1, you have perfect positive correlation. And that means the more one is going up, the more the other is going up too. Or the more one is going down, the more the other one is going down. All right, so that's just it. So I would like us to go to a use case. And this time around, I would encourage us to interact, because you are going to have to interpret this graph by yourself also. So I said, now that we have learned a technical tool in Python used for data visualization, it's important to know when to use each of these visualization techniques to glean. Thank you very much. Let me see, somebody sent me a chat just now. Okay, Abdullahi, thank you so much. All right. Okay, so let's move on. Okay, so I said it's important to know when to use each of these visualization techniques to glean information from available data. Now, I said, recall we stated earlier that visualization is a primary tool that is used in EDA. The other tool is descriptive statistics. Now, the primary goal of conducting EDA is to dictate pattern and uncover hidden information. So let's use this knowledge to carry out an extensive EDA on a real data set. So we are going to use the tips data set. So about the data set, I said food server tips in restaurants may be influenced by many factors, including the nature of the restaurant, the size of the party, that is the group of people of customers that are coming to eat, and then table locations in the restaurant. Restaurant managers need to know which factors matter when they assign tables to food servers. And so that's our problem that we want to solve. For the sake of staff morale, they usually want to avoid the appearance of unfair treatment of the servers, for whom tips, at least in restaurants in the UK, in the US rather, are a major component of pay. So in one restaurant, a food server recorded the following data on all customers they served during an interval of 2.5 months in early 1990. The restaurant, located in a suburban shopping mall, was part of a national chain and served a varied menu. Now, in observance of local law, the restaurant offered seats in a non-smoking session to patrons who requested it. And each record includes a day and time, and taken together, they showed the server's work schedule. Now, this is telling us, introducing us to the data in a sense, right? So we get to know what our data set is all about. And so now the goal here is to determine the important factors that influence the tip a server receives when they are assigned to tables. So the first thing you do is to import all the necessary libraries that you are going to be using for your EDA. So after that, you load in your data sets, and then you check if your data set has been properly imported into a data frame. And so that's what tips.ed is used for. Is also a method in we call it pandas, which is a library in Python also. So from there, I'm also importing the variable dictionary. You know, I was talking about data dictionary the other day. So now we can see that we have 7. Python start counting from 0. So we have 7 variables, and total bill talks about the cost of the meal, including tax in US dollars. The tip is the sum of money usually given by a client when they finish eating and they want to pay. Then sex is the sex of person paying for the meal, whether male or female. The smoker, are you a smoker amongst the party? Is there a smoker amongst the party? It's recorded as no or yes. And then we have the day of the week that the tip was given, the time of the day that the tip was given, and the group or the number of customers that came as a group, which is size of the party. And so I said, let's carry out the first step of EDA, which is the descriptive statistic. Now, this gives us a quick overview of the data set. Now, if you look at this, I said tips.info. What this method does for you is to give you information about each of the variables that are included in the data, that are contained in the data set. And so we have total bill, and it's telling me that I have 244. Non-null means that it is not missing. Okay, so 244 non-missing numeric variable. So float 64 represents continuous variable, right? And so we have tip also as a continuous variable. Then sex is recorded as category. And then smoker, category, day, category, and then we have size. Size Aha, size is a discrete numeric variable. So it's counted. And that is why it's telling me that it's an integer here. So also it's telling me here that my data set is clean. So I don't have any missing variable. So we can move on, missing value rather. So we can move on. So I said from here, we now know that the data set consists of 244 rows and 7 columns with no apparent missing values. And then we have 3 numeric variables and 4 categorical variables. Me. Hello, I hope I'm not speaking to myself. Hello. Hello.
Hello.
Hello.
Okay. All right. So can you hear me, please? I can't hear you. Okay, so let's move on then. Let's move on. You can mute your mic. Let's move on. Okay, so here, please mute your mic. So, hello, hey Brian, please mute your mic. All right, so when you want to, thank you very much. When you want to carry out a descriptive statistic, you use this method, tips.describe, and then I said include all. And what I mean is that I want to see both the continuous variables and the categorical variables, give me information on them. And so if you can look at this table right now, I said from here, we can immediately see that more men paid for the bill than women. And how do I know that? If you look under sex, you can see the top. Top means the mode that male paid. The most of the people that paid for bills are male. And then the top day of the week tip was given. The top day of the week that tip was given was a Saturday at dinner time. We can see that from the table, right? And then the average, looking at the mean, the average bill paid for a meal, was approximately $20. We can see it here, right? With an average tip of $3. We can see it here also. Now, is that good enough? That's the question you should ask yourself as a data scientist. Is that good enough? You will need to be to do research. You will need to be curious about that. So I said we will find out through our visuals. Okay, so this next one, I'm going to ask people to unmute so that you can, oh, I don't want to show this, excuse me. Okay, please give me some few minutes. Okay, so can somebody unmute their mic and give me, I said first, let's check out our target, which is the tip. So this is the tip. What can you say from this graph? What can you say? From this distribution, who can tell me something about this distribution?
Yeah, yes, tip is $2.
The highest tip is $2. Okay.
No, sorry.
All right.
It's people mostly give us $2, not the highest. My bad.
Okay, the most people give was $2. That's good. Any other one? Any of the observation you can make from this graph? There are still some observations that you can make. Please, can we talk so that we can move? I need to leave room for questions and I have to leave by 5:30. So you can help me by being fast about our interaction. Please unmute your mic and let's talk. Sorry, who spoke last? Was it Jubril?
Yes.
Hi, Jibril. Please help me by, can you state other observation you made from this graph?
The vertical axis, I don't know what is there. Is tips. The tips that the horizontal has was on the vertical.
Okay, so this is a histogram. What you have there is the count. The count of, it's just one variable. So we have the count of each bin that you have. When we have histogram, we usually divide our values into, we usually categorize our values into bins so that we can actually know the trend or the pattern of the distribution, right? Like you were able to say now that most of the customers actually paid tip around $2, right?
Yes.
Okay, so yeah, let's move on. So if you can see now from this histogram alone, I can infer that we have a lot of outliers. And what do I mean by outliers? If you can look at it, we see that somebody or some people paid an unusually high tip for their meal, right? And so it's far away from what most people paid, far away from the average or typical value, which is around $2, right? So let's move on. My interpretation is here, it is immediately apparent that we have few outliers, which means some client paid an unusually high tip for a meal. But how high? Let's dig further. Okay, so here we talk about the total bill. This is the distribution of the total bill. And I said here, the average total bill lies between USD $10 and $20. And then the highest paid is $50, as we can see here. And so also $50 is kind of far away from the average value. So, and then I move ahead to say, okay, please excuse me. I think I wrote down some questions that we're supposed to ask ourselves. Okay. On a normal day, I don't know how I missed that, but on a normal day, you're supposed to ask questions from your data. Okay, so when you want to carry out your EDA, you first actually look through each of the variables. And when you are done looking at each of the variables, then you can then start to ask questions. Okay, so let's move on. Okay, so I decided to do a joint plot between the total bill and the tip. And looking at it here, I said, looking at the scatter plot, let's look at it together. Again, we can see that total bill and tip are strongly correlated. And that means the higher the bill, the higher the tip. We can see how it's going up. Majority of the data set is going up. And then I said someone gave an unusually high tip for a lower cost meal. Why? Looking at it at the base here, you can see that for an unusual, for total bill that is around, excuse me, please. Okay, so somebody paid, okay, he's here. Somebody paid over $4 for a bill that is around $10, right? It's even less than $10. Okay, so you paid almost if not more than $5 for a meal that is less than $10. That's unusually high, right? So this is a good time to ask, what is the acceptable range? Okay, and I said some client paid unusually low tip for a high cost meal. Yes, it's here. So people that paid more than $40 for a meal are actually paying just less than $3 for tip. So that's an outlier, and I'm asking myself why. So this is a good time to ask, what is the acceptable range for a good tip? So when you're working on a project, you can actually go online to do more research, or you can ask the people that gave you the project some questions that crop up while you are carrying out your EDA. So I said, according to USA Today, I had to find out tipping at 15% is a good starting point, while the acceptable range is 15 to 20% for waiters at a sit-down restaurant. That is a restaurant that you sit down, you're not taking the food away. So for a $20 meal, a good tip is not less than $3. So for you to be paying less than $3, then you're actually tipping low. So for someone to pay a little above $5 for a meal that is less than $12, that's greater than 50% tip. We need to ask why. So what could have affected that? We have started asking questions. Is the time of day, or what is the time of day or day of the week? Now, is it the sex? What is the sex of the client? I said, what could have affected that? Is it the time of day or the day of the week? Is it the sex of the client? Or was it the person who gave the unusual tip a smoker and so was high that day? It's a valid question, right? And for those who paid a low tip for a high cost meal, why? And so I have my questions, and I want to actually go around the questions and begin to find answers. And so here I did a peer plot. So I plotted total bill against tip and total bill against size. And so let's see what I drew out from there. I said from the grid containing tip versus total bill. Okay, so we have, what I did was to now compare the male, the sex of the customers against their tip and their total bill. So if looking at, let me zoom in a little. Okay, so looking at this now, so blue is representing male and orange is representing female. So if you look at, this is tip against total bill. If you look at it now, the person who paid the unusually high bill was a male, or is a male. And then the person who also paid the unusually low bill, right? This is the unusually high bill, right? Is also a male. So whether they paid low or high, it's still the males that are doing that. All right, let me see what other things I got from it. I said, from the grid containing tip versus total bill, we discovered that the client who paid the unusually high tip was a male, and the one who paid unusually low tip was a female. So generally, on the average, women spent less on meal and tip less than men. And this is further proved by the bar chart below. I'll show you the bar chart. And then I said, what other information can you glean from the peer plot above? Let me go there. Time has been fast spent, so probably you will do that in your spare time. So let's go. So I want to confirm that what I wrote earlier is true. And so checking it here now, we can see that on the average, male actually paid $20, right? While on the average, female paid on the average paid less than $20 for a particular meal. So male paid more, and then looking again, male tipped more than female when it comes to tipping in a restaurant or in that particular restaurant. So let's move on. You know, I already put out my hypothesis. I said probably the person that paid unusually high bill for a low-cost meal was a smoker. So I want to find that out. So I tried to compare whether someone is a smoker or not against their total bill and their tip. And so blue represents yes. So you can see the person that paid high was actually a smoker. The unusually high tip was a smoker. So I said, bingo, the client who paid the unusual bill is a smoker. So does that mean that if the client is a smoker or if the party smoke, the tip will be higher? Let's find out. So you keep finding out. So that's the essence of exploratory data analysis. You keep finding out. And so what I did was here, I decided to use a facet grid to compare the time of the day and the smoker, whether the customer is a smoker or not, against their tip. And so I said, what do you think? If we had more time, I would have asked you to unmute, but probably you can do that in your spare time. And I said, my thoughts, while the client who paid the highest tip came from the smoker group, let's look at it. You can see here, smoker, yes, and the time is dinner. So you can see the outlier here for the tip is around this spot. And so, but looking at it too, you can see that majority of people also paid high. People there were more people who paid also at dinner time, right? So, okay, let me check whether this, okay, so we have people that are not smokers also tipping high too, right? So let's look at what I concluded. I said, why the clients who pay the highest tip for the smoker group, we find that the clients who don't smoke also pay well. Yes, and that's what I said here. Smoker, no. You can see that a lot of people also paid high tip here too, and they don't smoke. And judging from the scatter plot above, majority of those who tipped low for high cost meal were also smokers, while non-smokers were pretty consistent. So I think it is more of a question of what time it is. See the plot above. Dinner time seemed pretty packed than lunch time. Let's look at our histogram. You can see that here for the lunch time, it's kind of scanty, but we have more people actually patronizing them at dinner, whether they are smoker or non-smoker. So it's more a question of the daytime. So dinner time seemed pretty packed than lunchtime. So let's dig more. So using a facet grip, I decided to actually now compare the time of the day and the day of the week with the tip. You can see empty graphs here. So this implies that we have people on Thursday, right? A lot of people came around, but when it came to Friday, whether at lunchtime or at dinner time, we have few people. In fact, few people showed up at dinner time on Thursday, but there were a lot of people at lunchtime on Thursday. Then for Sunday, in fact, nobody showed up at lunchtime. But let's look at the evening, at dinner time on Saturday and Sunday. We have a lot of customers. And so what did this tell us? Okay, so this is also plotting against total bill, and we have almost the same pattern. So I said, wow, looks like dinner time on a Saturday is our best bet. We have a lot of customer paying well on Saturday. But I said that Thursdays and Sundays are looking almost the same. So quick question, you would think there would be more clients on Fridays, not Thursday, right? But Fridays are so sparse. Why? You need to ask why. And then why Thursday? So let me pause and let me see if anybody can answer that question. What is coming to your head? Why is it that, on a normal day, thank God it's Friday, we should have more people in a restaurant, but then we are having almost nobody at dinner time, but we have a lot of people at dinner time on Thursdays. So why do you think we have that in that restaurant? Please unmute your mic and make a suggestion. Please, is somebody there? I hope I'm not talking to myself. Can you unmute and talk?
I might be doing giveaway or something on Thursdays.
On Thursdays. Wow, thank you very much, Jibril. So who else would like to say something? Or should I call people? Precious, I would like to hear a lady's voice this time. Fadekemi, Precious, can you please make a suggestion?
Probably there's a discount on Thursdays. That's why we have more people that go there on
Thank you.
Thursdays.
All right, thank you. Precious. All right, so all our suggestions are good. Then I would like to also think that probably they serve the chef specials on Thursdays. Probably that's why we have, or discount. People love discounts. In fact, probably buy two, get one free, you know. Yeah, so thank you. So here I'm comparing the size of the party with the tip. And then looking at it now, you see that the higher the size of the party on the average, the higher the tip. So this bar plot clearly shows that the larger the size of the party, the larger the tip. And so what other information do you think we can glean from the data set? You can do that in your spare time. I'm sure there's more, and I encourage you to find them out. In the meantime, we'll make a quick conclusion in relation to our question. What factors matter when assigning tables to food servers? So this is my conclusion. The size of the party matters. So the larger the size, the higher the tip that will likely be paid. The cost of the meal, the higher the bill, the higher the tip. Then the sex of the client paying for the meal. Men are likely to tip better than women. Then the time and day. So Saturday night is our best bet. So I hope you have been able to say something concerning exploratory data analysis with Python. I welcome questions now very quickly. Thank you. Hello. Do we have questions? Temilade, are you there?
Yes, I'm here. Hi guys. Does anybody have any question for Mrs. Adeyinka Oresanya? Jubril, Bashirat, Oti, Idris. Okay. I think there's a question for you in the chat section.
Yes.
About
Somebody said, will you be able to share? I will send the slides to, I'm sure you registered. So I'll be sending the slides to the organizers and they'll be able to send it across. Yeah. Any other question? Okay, so I hope I'll be able to say something. Thank you very much. If you have any questions, probably you're working on your data set and something is not clear, you can reach out to me. Yes, please,
do you mind
reach out.
dropping your social media handles so that people can connect with you?
So again, Categorical. Let me go back to my slide. Can you see my screen, please?
Yeah, I can.
Can you see my screen?
I can see your screen. I believe they can see.
Okay. So if you can reach out to me on Twitter at Categorical, or just search Adeyinka Oresanya, Adeyinka J Oresanya, you'll see me, or send me a mail. Thank you.
Thank you so much for your time.
All right.
Ma. Thank you, Ma.
Yeah, thank you. Thank you. Thank you for having me. I appreciate it.
Yes.
Thank you everyone for listening to me. I hope I've been able to to explain a little better what EDA is all about. And thank you very much.
Thank you, Ma.
Bye.
Hi guys, let's not forget that tomorrow we have another session by 10 a.m. Mrs. Adeyinka Oresanya will also be on a panel session where you can get to ask her questions about her career as a data scientist, data analyst, how she started, where she is now. So your session is done for today. Then you can join us 10 a.m. tomorrow. The link will be sent to your email as it was sent to you today. Thank you so much, Ma. Thank you, everybody.
Thank
Enjoy
you.
the rest of the
Thank
evening.
you. Bye-bye.
Bye.
Yeah.
You can still register if you have not registered. Could you drop me your email? Okay, Precious, got it. We are done. Temilolua, we are done. We just finished now.
Oh, I thought